Hey everyone, so this project is basically about predicting how well your Instagram post will perform before you even upload it. You just enter things like your caption, hashtag, number of followers, and posting time. And the system uses machine learning model to predict your reach, likes, and engagement. So instead of guessing, you actually make a data-driven decision, right? The idea behind this project is simple. We all use Instagram. So why not build something that solves a real problem we face daily? If you're a first year student, my advice is don't just make random projects, build something relatable, something you personally use or understand. That's what makes your project stand out. Start simple, even a small idea like this can become powerful when you add logic, data, and a clean UI. So yeah, this is how data science can actually be useful in real life, not just theory.
So, talking about the code part, the project consists of three main parts. First is feature engineering, second is machine learning training pipeline, and front end and application layer. So, firstly, it will go from data set to feature engineering. After feature engineering, pre-processing pipeline will work. Then, after that, ML model will assemble, prediction will take place, and then it goes to the front end part. Then, front end will show you the output. uh, Talking about the feature engineering part, this file is responsible for converting raw Instagram data into intelligent machine learning features. Then the model extracts NLP feature from caption. These features help understand user engagement and behavior. I use text blob for sentiment analysis. Positive caption may generate higher reach and engagement. The system counts hashtag and detects hashtag presence because hashtag affect content discoverability. Then time data is cyclical. So Rs23 and R0 are close in real world behavior. So instead of raw numerical Rs, I use sine cosine encoding. So the formula here used is sine 2 pi h upon 24 and similar for R. Then this helped the ML model understand periodic patterns. I added domain specific features such as peak posting hours between 6 p.m. and 10 p.m. as most people are free at that time. Then follower count are highly skewed. Log transformation normalizes the distribution and improve model stability. Whereas machine learning model works with numerical data. So categorical post type and encoding into numbers. Now let's move to training model.py file. So the dataset is loaded using pandas and targeted variables are separated from input features. Here, 80% of the data is used for training and 20% for testing. I used sklearn pipeline for automated pre-processing. Numerical data is standardized and category data is one-hot encoding. So instead of using single algorithm, I implemented ensemble learning. The system combines random forest and gradient boosting. So using the stack architecture, then random forest basically reduces the overfitting by combining multiple decision trees, and gradient boosting improves the errors iteratively and increases prediction accuracy. So stacking combines prediction from multiple models using rigid regression as the final meta model. The system predicts multiple outputs simultaneously, reach, like, comment, and all. So here we did cross validation. Five-fold cross validation is used to check model generalization and reduces overfitting. Here R square measures how well prediction fit the actual data, and MA calculates the average prediction error. RMSE penalizes large prediction error more strongly. So the trained model is saved into job lib so it can later be deployed into applications. The app.js file acts as the backend server to the application. It handles routing, user request, form submission, and communication between Node.js and the Python ML model. So basically, Express.js is used to create web server and manage routes. Path module helps manage file path and directory paths. Then middleware is used to parse incoming form data and JSON data from the front end. This allows server front end assets such as CSS, JavaScripts, and images. EGS is used as a templating engine to dynamic render HTML pages. Then Multer is used for temporary file handling and media uploads. Then this route renders the home page. This route displays the forecasting input form. This route handles user prediction request. User input form is received as pre-processed here. Then user input values are extracted from the request body. The posting time is converted into usual features such as day of week, hour of posting, etc. These features are important because engagement changes depending on the post time. All processed features are combined into structured JSON object which is sent to ML model then. This backend uses child process to execute the Python prediction script. The processed input data is passed from Node.js to Python in JSON format. The backend captures prediction output and generated by the Python model. If any error occurs inside the Python script, it is captured and logged by std error. Then the prediction results are dynamically rendered on the result page using EJS. The index.ejs file is main user interface for the application here. It contains the Instagram reach prediction from where users enter caption, followers, hashtags, post time, region, engagement goal. The form sends this data to the backend prediction route using post request. And when the user clicks predict, the data is sent to the backend server for machine learning prediction. JavaScript is used for front-end interactivity, such as loading animation and file uploading previews. The forecast.egs file displays expert Instagram growth tips and engagement strategies. It provides recommendations such as best post time, hashtag optimization, reel engagement, audience interaction timing. So this page improves user understanding and provide data-driven social media insights. Layout.ejs file acts as the master template for the application. It contains common UI components such as navbar, footer, styling link, page structure, etc. Result.ejs prediction output page it is. The result.ejs file displays the machine learning prediction result written by the backend, like predicted